Hello, everyone. In our last lecture, I was having some technical difficulties with the recording, and it looks like the chunk explaining marginal costs and benefits got cut off a little bit. So we're going to go back to that. I'm going to go through and show you how to calculate marginal costs and choose that optimal combination. So in the last video, we talked about how if we're trying to find like the best combination, the best level of production, or how many waffles you should eat, whatever it is, we're going to use a rule where we say marginal benefit is greater than or equal to marginal costs. And if it is, then we'd say, yes, you should purchase that or produce that or whatever it is. And if marginal benefits are less than marginal costs, then we say no. So marginal means extra. So if we're adding one more thing, what is our extra cost and what is our extra benefit? And in this example with NASA rocket launches, we have a constant marginal benefit of $6 billion each. So every single rocket launch is going to have that same extra benefit. We don't have a constant marginal cost. We can actually find marginal anything by looking at the total. So the total tells us how much it costs to do all of them together. So the total cost for one rocket launch is $4 billion. The total if we do 2 is $9 billion, total for 3 is 16, and total for 4 is $26 billion. Since marginal is extra, we just need to look at the difference between the totals to find the marginal. So total of launch 2 minus total of launch 1 equals the marginal cost of launch 2, or the total of launch 3 minus total launch 2 equals the marginal cost of launch 3. Okay, so we're just taking the total, subtracting the last total, and it's going to tell you how much extra it costs to do one more. So in this example, we already have it written here in the table, but if this was left blank, we could actually calculate it. So what we would do is we'd say, okay, for the first one, we're just going to assume if it doesn't tell us that 0 launches is going to cost $0. If we're talking about actual government programs and NASA, that's not the case. It may actually cost money, but we're just going to assume 0 and 0 if it doesn't tell us. So we'd say the marginal cost for the first one is $4 billion. Okay, it's going to be the same as the total because we're just subtracting 0. For the second one, we need to subtract the cost of that first launch. Okay, so we're spending $9 billion total. We want to subtract the $4 billion from that first launch, and then that gives us a marginal cost or extra cost of $5 billion for the second launch. Then we want to do the same thing for the third launch, so 16 minus 9, so the cost of the other two launches. That gives us an extra $7 billion. And then the last one, 26, minus the total cost of the last one, which is 16. And that tells us that that last launch is going to cost us $10 billion. And so we're just going to go through here and we're going to compare the marginal costs and benefits, and we're going to apply our rule. So $4 billion in cost, $6 billion in benefits. We would say, yes, we should do this first one. The second one, $5 billion in costs, $6 billion in benefits. We're going to say yes to do that second one. The third launch has a $7 billion extra cost and only a $6 billion extra benefit, so we're going to say no. And then the last one is a $10 billion extra cost and a $6 billion extra benefit, so we're going to say no. You can also go in the reverse order. So if we wanted to calculate like total benefits from however many launches, the first one is 6. The second one, because it's going to be 6 times 2, right? So 12 billion, 18 billion, and then 24 billion. Okay, so if you know the marginal, you can calculate the total. If you know the total, you can calculate the marginal. In a lot of examples and tables we have, I'm going to give you the totals, and you're going to have to calculate this. Okay, so getting good at this now will be very helpful for you during the semester. So in this case, we would say if the marginal benefit is $6 billion, then NASA should choose 2 launches. 2 is going to be their best choice. And then they should just use that money. If they have 16 or 20 billion, they should use that money for something else. If our marginal benefits or costs change, we're going to get a different outcome. So if for some reason we have a marginal benefit of 10 billion each, okay, so instead of 6, it goes up to 10 for whatever reasons that we don't have here. In that case, we would say yes to all of them. So 4 billion is less than 10, 5 is less than 10, 7 is less than 10. And then this very last one, they're equal. And when they're equal, we're always going to say yes. And that is, we'll get into some more of the reasons why later, but we're including opportunity costs and other things in these costs. And so if they're equal, we're saying that the other option for the money is not going to give you anything better, and you're indifferent, so you could pick the other thing or this. But since we're only going to have one option, we're just always going to say yes when they're equal and only no when it is less. Yeah, we are going to do this a lot during the semester, so definitely practice. Let me know if you have questions or you're stuck on anything.